All right. Welcome everyone to High Rounds. Today we're lucky to have Dr. Eddie Hill, who is our wonderful third year ID fellow here at UCSD. He currently works in Dr. Omar Akbari's lab, working on genetic control technologies for vector-borne diseases. And he's going to be talking today about New World Screwworm, eradication and emerging risk. So go ahead, Eddie, take it away. By the way, I'll kind of monitor your chat, and if anything comes up, I'll probably try to hold it unless if it's like really super pertinent to what's going on. Okay,
Okay, great. Thank you, Dr. Lee.
thank you.
And thank you all for having me. So this work is not as clinically relevant as most other topics discussed during high rounds. I think the last two were HBV and Mpox. But I think this is still, this is a focus in my lab currently, and I think it's definitely worth talking about. So this is a timeline of significant livestock diseases, disease events in U.S. history. The Europeans brought brucellosis and M. bovis to the Americas. So we've had issues with those two diseases since then. We've also dealt with a Mycoplasma mycoides big epidemic in the 1800s. We had tons of ticks spreading babesiosis in Texas in the 1860s, 1940s. We had a couple different viruses affect cattle and pigs. We had the foot and mouth virus, which is different than um, the foot and mouth disease that we have in humans. And then more recently, we have avian flu. Um, I left out one important livestock disease threat, which is the focus of this talk, which is the New World screwworm. And so you can see that we had a big issue with this infection in the late 1800s and the 1940s and 50s primarily, and then it's recently reemerged. So the title of this talk is New World Screwworm, which I'll abbreviate as NWS, Eradication and Resurgence. The objectives are to understand the basics of the screwworm, review the historical eradication using the sterile insect technique, discuss the recent resurgence, and then just have like a very broad overview of possible next step technologies used to combat this disease. I have no significant disclosure. I did adopt a couple slides from Dr. Mehta's and Dr. Chansey's talks. So I thank both of them for that. I think Dr. Mehta will be talking about the New World Screwworm at upcoming ID rounds in a few weeks. So yeah. So the New World Screwworm fly is about the same size as a common housefly. Let's go back to the picture actually. So it has these big orange eyes. It's like generally metallic green or blue, and then it has these three black stripes at the end of it. Um, the term screwworm refers to the screw-like shape of the maggots that feed on the host animals. Um, these were originally endemic in the southern US, Mexico, Central America, most of South America, and parts of the Caribbean. This map is fairly accurate. Um, it's typically endemic in warmer climates, and the larvae cannot survive temperatures below 46 degrees Fahrenheit. Of note, the females only mate once, but the males mate multiple times, and that'll become pertinent when we talk about control strategies. And the problem really is that these females lay thousands of eggs in or near wounds of animals, humans, pets, and then also sometimes in orifices as well. So just like healthy mucosa, thinking mouth and nostrils. And then these larvae hatch and then immediately invade healthy tissue. And this is distinct from almost all other um, fly diseases, which generally invade like, non-viable tissue, but we're talking like healthy tissue in this case. Um, the New World screwworm primarily is a livestock pest. It mostly cattle, but it also affects, other wildlife, we're thinking deer, pets, and then also humans as well. Here's the life cycle of the screwworm as depicted by the CDC. So the adult female flies are attracted to odors from like open wounds and moist mucosal surfaces. Even like a minor injury, like a tick bite, might be like a prime location for these females to land. Then they then they lay hundreds and thousands of eggs directly into that wound or natural body opening. These eggs hatch, and then they kind of quickly dive deep and penetrate and feed on the living tissue. And again, this is a unique attribute of this bug compared to almost all other flies. And then this can cause very severe and progressive tissue destruction. Again, we're talking like hundreds and thousands of maggots. After feeding, the larvae kind of drop off the host and pupate in the soil, and then 1 to 8 weeks later, they emerge as adult flies, and the cycle is reborn. The next picture is like somewhat gross. Like I tried to choose the least gross pictures. So recommend shielding your eyes if you're a little squirmy. But this is what you might see on some livestock, which is just a fresh, seemingly like, this is healthy tissue being infested with growing like tons of larvae. And you can see these metallic green female flies in the picture as well. So what we're talking about here is myiasis, which is an infestation of larvae or maggots in tissue. There are three general categories of myiasis in humans. The first is furuncular myiasis. So this is this is just like a single larva. I think a tip would be that they traveled recently, or that this is a recurrent abscess, or it looks like a spider bite that's not going away. It generally has this appearance in this picture right here. Um, and it's relatively kind of a benign disease. It's caused by bot flies or tumbu flies. And then the second category is wound myiasis or facultative colonization. So this is typically what you might see in the Hillcrest ER. So these are larvae that feed on non-viable, poorly perfused tissue. So you think vascular disease, neglect, diabetes. There isn't a lot of tissue aggressiveness, and it's fairly superficial infection, and it's relatively, it's pretty easy to remove all these larvae. And then this is very distinct from invasive wound myiasis, which is obligate tissue destruction, meaning you need healthy tissue. And this is almost exclusively New World screwworm, Old World screwworm. There's a couple others, but it's really a small group of flies that do this. So again, we think of like a very severe infection. We see blood, we smell it, it's a very terrible smell, very deep wound, rapidly progressive. It just looks bad, basically. And when you see something like this, it would be, a veterinary or a public health emergency. And so that's kind of the field that we're in for this talk, is we're talking about the New World screwworm invasive wound myiasis. So risk factors for a human New World screwworm myiasis. So open wounds. Again, it doesn't need to be like a big old wound. It can be kind of a small, just nick in the skin that can precipitate this. Conditions that compromise the skin is another risk factor. So this is an image of scalp myiasis in a very healthy 12-year-old girl who lived in Colombia and had psoriasis. So the psoriasis obviously predisposed her to this condition. And then typical risk factors, so immunocompromised, diabetes, poor hygiene, you know, like working with animals, living outside. If you're unable to kind of, um, I don't know, protect yourself from flies and insects bite, that's another big risk factor there as well. So as I mentioned, this is generally considered a public health emergency. So if you have any concern for a New World screwworm infestation, see a healthcare provider. The healthcare provider should notify public health right away. All the larvae have to be removed. That's how you treat the disease. This sometimes requires surgical extraction just because these are really deep and rapidly progressive infestations. And they obviously require like serial monitoring thereafter. And then the CDC makes the point to not put the larvae outside in the trash bag. So yeah, but yeah, we just need to like kill it right away. So just put it in a kind of a leak-proof container with ethanol. It should kill it, and then send it to the lab for identification. And then these patients will most likely need antibiotics for treatment of secondary infections. So, as I've hopefully impressed upon you all, this New World screwworm is a severe or can be a severe and invasive disease that can cause a lot of harm. And it was a big problem in the 1890s and through the 1950s, particularly in the cattle industry. There were a bunch of different control methods that people were using at the time: surveillance, wound inspection, uh, just removing the larvae, insecticides, larvicides, quarantining, and just generally restricting the movement of livestock. But despite this, by the 1940s, it was definitely one of the most economically destructive livestock pests that we've ever dealt with. Um, so I think, yeah, there was just as far as the economics, which is most of the data that we have. I mean, tons of lives were lost, but and economically, it was 800 and 900 million dollars a year in the States. And then tons of cattle died, humans were infested, pets, wildlife. It was a really big deal, and all these control methods like wound care was super labor intensive, financially, and cost a lot of money. So um, it was a big issue back then. And so because the existing control methods weren't working, and we were basically still dealing with an unchecked epidemic back then, we had to figure out a completely unconventional method of control, and that's where these two gentlemen came in. So this is uh, Edward Nipling and Raymond Bushland, who were USDA entomologists working in Texas at the time. And they developed a sterile insect technique to eradicate the New World screwworm. So the idea is let's mass produce these flies ourselves, make sure that they're sterile, release them all into the environment, have them mate with wild type females, and then, that would precipitously drop the population or collapse the population. That was the thought, at least. And this all kind of hinged on the fact that we knew that females only mated once for New World screwworm. So yeah, they only mate once. Let's give them a partner that is sterile, so that they can't have offspring. Basically, is the idea. So here's an infographic that generally shows the idea behind the sterile insect technique. So mass produce all these screwworms. You basically use kind of either, I mean, they use meat in a day, but they eventually artificial larval diets. And then the females would lay eggs on warm substrates that kind of mimicked wounds. And then you would radiate all the insects. This was a little tricky because you want enough radiation to sterilize the insects, but not to kill them or to decrease their competitiveness. So it was tough to figure out the exact right amount of radiation that was going to be effective. Um, and then this wasn't in the infographic, so I wanted to add it. But important part of this, the sterile insect technique is surveillance, right? You need to make sure that this population is dropping. So the only way to do, you need to be able to distinguish between the released insects and the wild type insects. So what they did is they basically marked the sterile insects with a kind of fluorescent dye powder, which could be revealed using UV light during surveillance. So anyway, so mass produce, they radiate to sterilize, they tag them with a fluorescent dye, then they release all these insects from these planes in target areas, areas of high infestation. And then the sterile males would compete with the wild type males for the females. And again, females only reproduce or only mate once. And then the idea is that these males are no longer able to bruise eggs that need kind of warm, viable tissue to survive, drop the population basically. So the first field test trial occurred in Curacao, which was an island in the Caribbean, or it is an island in the Caribbean. It was chosen because, first off, it has screwworm. Second off, it's geographically isolated. And so what they did is that they released all these sterile flies onto the island. They released them at a ratio of like 10 to 1. So, 10 sterile males per one wild type male. Um, and then I have the data right here. It looks like they didn't they did not notice any new screwworm eggs 9 weeks after starting releases, and then the population was completely eradicated by 5 months. And so this was the first demonstration that SIT could eliminate an established insect population altogether. It was a big deal at the time. Again, 55. This happened in 55. So soon after, they started implementing the SIT or sterile insect technique at a large scale. So they started in the southeastern continental United States. Then they moved westward and then south through Mexico and Central America. This was led by the USDA, who can work closely with other governments. Originally, the sterile fly production was centralized at two large facilities, one in Florida and Texas. Um, so they produce them there, then they chill the flies to delay emergence from the pupae, and then they ship them to regional airports across the country, and then they release the insects over target zones. And you can see one of these releases in this picture right here. And these releases occurred weekly, at least for 6 to 8 weeks, but sometimes up to 6 to 12 months, depending on surveillance data and yeah, I mean basically like how infested, how much or how many screwworms were there at the time. And so while 10 to 1 ratio was used in Curacao, they generally they bumped it up for the real world. So it was above like 50 to sometimes more than 200. So again, that's like 250 sterile males for every one wild type male. So that's why surveillance data was so pertinent because that's how they would determine how long to treat and then the ratios as well. And then the big deal was surveillance. So this dictated how long to stay in one spot and when we could kind of move the attack to a different location. So surveillance looks like basically looking at livestock inspection, wound monitoring, trap networks, and then also veterinary reports as well. And then basically only after there was a repeated confirmation of local absence did they move the eradication efforts elsewhere. So they required a long time for eradicate or absence before moving. So this, oh, sorry. So this is a map showing the eradication effort. So you'll see we started, the Curacao field test was in 55, then real world effort started in 57. It took us 9 years to get rid of the screwworm in the United States, ending in 1966. The USDA originally thought about stopping things in northern Mexico, but they realized it didn't make any sense at all. So they pushed things south through Mexico and Central America. It didn't seem like pushing the project into South America was even considered. Probably it's just deemed to be kind of infeasible, the vast expanse of that continent. So they stopped at the Darien Peninsula in Panama because it provided a geographic bottleneck. And then it was just a lot easier to saturate that area with all these sterile flies as opposed to kind of a larger area. So this is a summary slide of the eradication efforts. So again, the scientists were able to eradicate the New World screwworm in the U.S., Mexico, and Central America, but then um, just things remained endemic in South America, Cuba, Haiti, and the Dominican Republic. The firewall at the Panama Isthmus was led by COPEG, which was a Panama United States alliance, still active right now. Um, There at that firewall, they created or they reared 20 million sterilized screwworm flies every week and release flies every day or every other day to maintain like constant control of the Darien Peninsula to prevent northward um, migration of this infection. They also had very careful animal movement control checkpoints, and then again um, to surveillance, wound inspection, larvicidal treatment. So it was just a kind of multifactorial effort. This is their cool emblem. I thought I'd include it because I think they did a good job there. Um, this is the facility in the Darien Peninsula that has kind of kept things at bay for so long. Just this one facility. It's really incredible. The barrier was maintained for about 15 years before there was a resurgence in Florida deer in 2016. People don't know what happened. They think that there was just a single introduction event rather than multiple introductions, but I'm unclear about how they made that determination. Um, so basically, what they did is from that one facility in Panama, they just shipped flies up to Florida and um, basically saturate the area with these sterile screwworms. And then within 6 months, there was no longer screwworms in Florida. Okay, so getting to the meat of the subject, which is New World screwworm reemergence in 2020. So let's talk about what's going on today. Um, as of 2 days ago, we have our first case of New World screwworm in the United States since that deer issue in 2016, 2017. So they found screwworms in a calf in southern Texas, basically right along the border. So again, this is like hot news just 2 days ago. The problem was basically first picked up in 2022. And then the screwworms have been steadily moving northward since then. So, besides the one Florida outbreak, we had really great control. COPEG, had a really good firewall at the Panama Isthmus from I think it was 2001 to 2022. And then we've seen this steady march northward back into their territory that they previously lived in. And this is an old map again. So now we obviously are now seeing it. We now have a case in Texas. So Mexico has really great high resolution data on this issue. So this is what I picked up from this is November 2024 to mid-May 2026. There were 24,000 cases in animals and then basically 300 cases in humans. This has resulted in countless cattle deaths and two human deaths in Mexico alone. And some other stats. So, according to the CDC, as of what was it, Monday, across Mexico and Central American countries, there have been 172,000 animal cases and more than 2,100 or about 2,100 human cases. There's one travel-related human case in the United States in August of last year in a Maryland resident who had traveled to El Salvador. And then as of January, six human deaths from this disease. Deaths from, like in both animals and in humans, occurs from massive and unchecked infestation. So, this is one example from this recent epidemic. This is a patient in Ecuador who died quickly upon arrival to the ED. It sounds like they had a severe had a larval infection in their oral cavity, and then it migrated to the oral pharynx, and they died that way. But it's usually kind of again unchecked infections, really, really dangerous. So one of the questions I had is, what's explaining this resurgence? Like, how did this happen? Copeg was doing such a great job down in Panama. I mean, basically, people don't know yet. They have people suspect it's multifactorial, but there's a possibility that there were interruptions in sterile fly production during the COVID pandemic. Many people or many news reports are suggesting that there's been a uptick in illegal cattle imports from South America into Central America, and that explains it. I don't exactly know, why surveillance is so difficult in on the Darien Isthmus, but that is frequently, it's a commonly cited reason why this epidemic has reemerged. And then, obviously, one of the biggest questions I have is: are these wild type flies now outcompeting the sterile flies, or is it just not working anymore? The sterile insect technique that we've relied upon for 20 plus years. So the response, the USDA has responded to this epidemic by doing multiple things. So they've closed the five southern ports for livestock trade. So those are all closed. You can see that in this map right now. This is recent. This is of spring 2026. We've increased sterile fly production. So again, Copeg was treating or rearing 20 million flies per week back when things were in check, and now it's making 100 million flies per week. On top of that, we are building um, new huge sterile fly facilities in Texas and in Mexico to help complement or supplement the Panama operation, which is the only thing in operation right now. So I think I saw a news report that the Edinburgh, Texas construction had like the goal was to open it in November 2027, but given that we now have evidence of this this issue in Texas, you know, we'll see. We'll see how quickly they can get that done. And then the USDA has committed so much money to research funding to help combat this issue. I think it's $100 million. So, I think there are a few possible next steps that I wanted to discuss. I won't go into too much detail because these are largely theoretical right now and have been demonstrated in other insects, but not in New World screwworms just yet. But they're definitely worth discussing. So the first thing is let's try the SIT, but this time with sex separation. So to explain what this is, let's just revisit what we've been doing with New World screwworms up to this point. So basically, we mass rear these insects, we irradiate them, we mark them with fluorescence, we release all the insects. Sterile males compete against wild type males, offspring and population decline. The key feature here is that SIT up to this point has relied on mixed sex releases. So that is to say, we've been releasing both sterile males and sterile females into the environment. Because it's not females that are the issue, it's the laying of eggs, which is the issue. But there might be some potential problems with this approach that haven't been addressed quite yet. So are the sterile females mating with the sterile males, leaving the wild type females to kind of reproduce with wild type males. That's one issue. And then during the irradiation phase, we have to irradiate both sexes at the same time, and females require more radiation than the males. And there is a question of whether or not increased that or whether or not that radiation is too much. So does the increased radiation needed to sterilize the females actually diminish sterile male fitness and competitiveness? So those are a couple of the questions I came up with for the classic SIT approach in New World screwworms. So for this reason, scientists are looking at introducing sex separation into the SIT. So, we already do this with agricultural pests like the Mediterranean fruit flies, and then we also do this with Aedes and Anopheles mosquitoes. So in this new version, what we do is very similar. So we mass rear all the insects, then we'd somehow separate the insects. Doing so in an industrial scale is hard. And then we would basically get rid of the females, just use the males thereafter, sterilize them, release them, and see what happens, basically. So again, this is SIT with sex separation. So as I as I mentioned, I think the biggest question, how do you do this at an industrial scale? Like how do you like separate the sexes? Yeah, so I mean in other insects we can rely on phenotypic differences. So female mosquitoes and male mosquitoes look so much different. The females are always so much larger, so you can just separate with like mechanical sieves and density like separators. And just separate the sexes that way. But unfortunately, there are no substantive, phenotypic differences between male and female screwworms. So it's not the best option for this problem for this species. The rest of this image is way too busy, and this is for mosquitoes primarily. But the general idea is that if we can't separate by inherent physical differences, the idea is to create physical differences that we can separate by, or create kind of survival differences in the sexes through genetic manipulation. The general flow is let's introduce a transgene into the genome of a screwworm. And this transgene would have a sex-specific genetic switch that would only be very specific for one of the sexes. So the idea is that both sexes would inherit the transgene, but only one sex activates it, because either the males or females process or regulate the gene differently. And then that difference can be used to create a visible marker such as fluorescence, which we can easily separate New World screwworms if they fluoresce differently. There's like optical separators, or to kind of selectively eliminate females altogether. Basically you could create a transgene that um, is lethal to females because they alternatively splice the gene differently than males, for example. So that's SIT with sex separation, which I think people are now beginning to work on with haste. Again, let's introduce these new genes with sex-specific expression that allow scientists to separate males from females, and then continue with the rest of the technique. So, like, then just use the males, radiate them, release them, and see what happens. I won't cover this right now, but the other two technologies that are being investigated to fight this are precision-guided sterile insect technique and then gene drives. So these are technologies that don't require radiation to sterilize. The sterility is built into these CRISPR-Cas9 systems. And so you use CRISPR-Cas9 to induce sterility rather than radiation, which has some benefits. Other next steps, there aren't any medications that have been found to be helpful. I didn't really look at into that for this presentation as much. Ivermectin has been shown to be effective in some case studies, but not consistently so, so it's not recommended. Um, and I know it's early, but that's the end of uh, the presentation. So if anyone has any questions, please let me know.
Great. Thanks, Eddie. So there were a few comments. One from Nettie. Seems a shame that Cuba and Dominican Republic were missed. Islands should be easy to eradicate with this technique. I think the SIT you're talking about.
Yeah. Hmm.
Any
Agreed.
comments on
Agreed.
why they weren't, you know, targeted, or is that politics?
I think it's politics. I think we had a very U.S. centric approach to this disease at first, and I'm hoping that they change that moving forward. But yeah,
Yeah. Yeah. And then Paloma said, New World screwworm is gusano barrenador in Spanish. So just enlightening us on that.
yeah. Thank
Uh,
you. I appreciate it.
I'll go ahead and open it. Those were the questions. So Nettie, oh, a comment here. Very interesting. Gross but interesting. Gets you thinking about improvements in Technic Quest to control mosquito and tick illnesses. I don't know if Nettie, if you want to unmute or
No, it was just a typo. Thank you. It was
got
very
it.
interesting talk. I just meant, it gets you thinking. I mean, I certainly hope this is not going to move its way to San Diego, but we have, other mosquito and tick-borne diseases that I'm hoping we will start to learn better eradication techniques. So it's very interesting.
Yeah, agreed. Agreed.
So I'll go ahead and open it up. And I do see here Natasha put in a dashboard that tracks New World screwworm cases. Anyone want to ask a question?
I'm going to pick up my last question, which is, are you aware of any of the similar being used for, say, tick-borne illness in New England and things like that? Is there research, similar techniques for other vectors and pathogens?
So a lot of the so that sex separation, PGSIT and gene drives are actively being used in mosquitoes already, and they're used in real world currently. Um, and then also with some agricultural pests, there's some coddling moths, there's some Mediterranean fruit flies. The agricultural business has a lot of money invested in these technologies, and we already use them in the United States. As far as ticks go though, I think there isn't a lot of research done on that. Our lab tried some tick transgenesis, same kind of thing, SIT, and or kind of like genetic, like kind of SIT-like technologies, but it's really hard to cause transgenesis in ticks, and I don't think any lab has figured that out quite yet in the United States.
Looks like Tom had a question. He may have missed it, but he said, "How do you remove them in humans if you see someone with it?"
Yeah, you remove them with tweezers, and then sometimes you need surgery, and then you go back in a day later. Sometimes people put kind of how we some people remove ticks this way too. Put like some sort of thick moisture over the area, and they don't have any oxygen, so they might come up to breathe and remove them that way. Um, I think those are the ways that people have done that before.
Yeah, in my experience, so I actually had a case when I was an intern, first year intern at UCSD at the VA, and so as the lowly intern, I was tasked with removing them with tweezers. So I absolutely remember doing that a long time ago. Uh,
Oh, well, that's
looks
perfect, Dan. How do you have to grab them right down at the base to avoid leaving the head in, or what's
Yeah,
the
I think you try your best, but sometimes yeah, you know they do stick a bit and then you have to kind of retweeze the you know the head to make sure you got it all. But it was a I don't know, it was a fun project, I guess, to as an intern. But yeah, it was my experience. It was quite extensive, so there was quite a few to remove, to say the least. So yeah. So Lisa's asking here, have there been any known animal or human cases in San Diego County that we know of? And I think Natasha answered it a bit, none that she believes of, but I don't know if Eddie, if you know anything more.
No, I agree with Dr. Martin. Yeah, I think it's just in Texas right now. Um, yeah.
Okay. And I see here Natasha says San Diego County has been testing animals with maggots for New World screwworm for over a year. This is an active area of surveillance. If anyone's working in surveillance and prediction of NWS, let her know. Natasha, do you want to
Yeah,
say anything else?
sorry for all the chats. Happy to
No,
be on
no.
camera. Thanks very much for a great presentation. I just wanted to flag that New World Squirm is definitely a key area of interest for the county. We, as part of the CDC-funded Resilient Shield, which is our Center for Outbreak Analytics and Modeling, we have been working with this um, uh, with with them on this question for over a year. When this was initially kind of um, raised with the case in Texas. So I think it was maybe last April or so. We opened a ticket and we started to pull together kind of surveillance data in terms of tracking the progression through Mexico. There are some people in the UC system that have been working to model the progression, especially because they have been able to collect really interesting cattle transport data and believe, at least in Mexico, that sort of active transport of cattle is one of the main drivers that accelerates the spread of this. So anyway, all that to say that this is on our radar, and if anyone is working in this area, we would love to have your collaboration because that would be great.
Thank you.
Great. Uh, any other questions? No. All right.
I
Well,
had a
thank
quick
uh-huh.
quick shout out. I don't know if people saw this, but Aaron and Shira had kind of forwarded this to the group. This webinar about kind of emerging diseases, and they'll cover vector-borne diseases as well. But it should be in your email. This webinar today at 11 from Stanford. So it should be pretty interesting. I think they might cover obviously cover hantavirus, Ebola, but also some other, vector-borne diseases too. So
Great. So with that said, do you think that there's any relationship with global warming, or does temperature somehow improve the, you know, screwborn mating. I don't
Yeah.
know. Uh,
So I looked into this. People don't think it might be contributing, but a very minor contribution. I think they mostly think it's these like illegal cattle imports
sure,
and just breakdown of surveillance, or we don't exactly know, but maybe potentially
sure.
they are very temperature sensitive. So
Okay, great. Well, thanks everyone, and thank you, Dr. Hill, for an excellent talk. And everyone have a great weekend. We'll see you next week. All right. Thank you.
thank you.